they converge and when they diverge. So for what values of x is the series n equals 0 to infinity n factorial x to the n convergent. I see a factorial in my series. Does that tell you which test to use? Ratio test. Anytime we see a factorial, use the ratio test. Okay, so let's do that. When we compute using the ratio test, it's an plus 1 over an. N plus 1 factorial x to the n plus 1, n factorial x to the n. Okay. And remember, we group our like terms together. They're already grouped together. My first term on the top and bottom are both factorials. My second term on top and bottom are both my powers of x. So I'm ready to simplify. What's something we could do to simplify here?
We pull out an n factorial on the top.
So I'm going to rewrite. This is n plus 1 times n factorial. And then what else?
We could pull out an x to the n
Okay.
on the top.
Yep. So then this would be x to the n times x over x to the n. What could we do from here? Your goal is to simplify.
So just divide that.
Yeah, just cancel them. Divide. So if I look, I have n factorial and n factorial. Those will cancel. X to the n and x to the n cancel. So I'm left with two things. N plus 1 and x. So now let's deal, yes.
I have a question.
Mm-hmm.
When we pulled out the x to the n out of the x to the n plus 1, why is it not x to the n that's left? Because you just subtract 1 from the power, right?
It's x to the n is what's left, yeah? So when you,
Okay, yeah.
yeah, you said it right. I think that's what is written there. I took 1 away and I'm left with x to the n. So now let's try to get rid of our absolute values. N plus 1, is that positive or negative? Positive. The absolute value of a positive is just itself. What about x? X is a variable, right? So it's a placeholder for a number. So I'm not sure. It could be positive or it could be negative. So that part has to stay inside of an absolute value. I can't get rid of it. Because it depends on what value of x I'm choosing. It could be positive or it could be negative. Now we're taking the limit as n goes to infinity. So you're thinking about this absolute value of x here. Pretend like you've chosen a fixed number for x. So this here is just a constant, so we can pull it out in front. Okay, so absolute value of x, the limit as n goes to infinity, n plus 1. And now we need to calculate this limit. It's infinity. And so it doesn't matter what this constant is, the absolute value of x, as long as x is not 0, this is infinity. provided x is not 0. And this was a power series that was centered at 0. If I go back up, look at my power series, it's x to the n, so it's centered at 0. So I know it converges at a, which is 0. But it turns out that's the only value that it converges for. Okay? So the series diverges when x is not equal to 0. The ratio test says if you get a number bigger than 1 or infinity, it diverges. And the series converges only when x equals 0. Okay, converges for that one value, and that's it. Okay. So there's only one value where this power series